In this video, we will use the factorial doubles or double factorial to generate the Taylor series expansion of the Bessel and the reverse Bessel over the values of x from negative 1.1 to positive 1.1. Our value of k is from 0 to n, where our value of n is equal to data validation over the range 0 to 10. And OK and save. We can start from 0. And the value of k is from 0 to n. So sequence n plus 1 column starting from 0 incremented by 1. So that at n equals 1, then k is 0, 1. N equals 2, k is 0, 1, 2. N equals 3, k is 0, 1, 2, 3. And the value of a, the coefficient, which is equal to array formula, factorial, that's the numerator, factorial, n plus k. So n plus k. And enter. If this is empty, this should be 0. We'll correct this. So if n is empty, so n is empty, then 0. Otherwise, calculate. Now it's corrected. We continue with the denominator. The denominator has two parts, so start with the first part. The first part of the denominator divided by, the first part is factorial n minus k. So factorial n minus k, n minus k. That's the first part. The second part. The second part is double factorial 2k. Fact double 2 times k. 2k. Now we can complete the Taylor series expansion. So this will be equal to array formula, series sum of the x values raised to the power k, where k starts from 0. Starts from 0, incremented by 1. And the coefficient, it will be this range. Likewise, the reverse Bessel, which is array formula of the x values raised to the power n minus k. So n minus k starts from n, incremented by negative 1, because that's negative k, where k starts from incremented by 1, so negative k. And the coefficient will be this range. And this is series sum. So this is series sum. So series sum. Series sum, the summation of x raised to the power n minus k. N minus k starts from n, incremented by k, where k has the interval of 1, so negative 1. And the coefficient will be this range. And we chart this. Insert chart. And we use scatter chart. And we show the trend line. For series, the trend line. The type, polynomial. The degree, polynomial degree 10. For the label, use the equation. For the legend, position at the bottom. So here's our trend line. And polynomial of the Bessel and reverse Bessel polynomials. Next, we calculate the polynomial regression coefficient using LINEST. To do that, we complete the LINEST method. Starting with this will be array formula. Array formula of the x values raised to the power 0 to 10. Now we can calculate LINEST. LINEST data y and data x. This will be LINEST data y and data x. Let's compare our polynomial regression coefficients with the chart. So we begin with the n equals 0. At n equals 0, they're the same. X, the coefficient of x to the 0, 1. Coefficient of 1, they're the same also. 1 plus 1x, they're the same. The rest are 0 because they are very small. At n equals 2, here we have 3, 1, that's 3, 1, 3, and 1, 3. So this is the reverse of this. At n equals 3, the Bessel polynomials, we have 15, 1, 15, 6 for x squared, 16, 15, x cubed, 1, 15. The rest are 0. At n equals 4, for x to the 0, 105, 1. Coefficient of x is 105, 10. Coefficient of x squared, 45, 45. Coefficient of x cubed, 10, 105. And coefficient of x to the 4th, 1, 105. And n equals 5. Coefficient of x, or x to the 0, 945, 1. Coefficient of x, 945, 15. Coefficient of x squared, 420, 105. Coefficient of x cubed, 105, 420. Coefficient of x to the 4th, 15, 945. Coefficient of x to the 5th, that is 1, 945. So this is the Bessel polynomial, the red one, and the reverse Bessel polynomial. This completes the use of Taylor-Maclaurin SERIESSUM, LINEST polynomial regression to generate the double factorial to generate the Bessel and reverse Bessel polynomials in Google Sheets.